Trigonometric identities. The Pythagorean identities all stem from this first equation, sine squared theta plus cosine squared theta equals to 1. So that's the only one you really need to know, but the other ones all come from it. So when you divide the entire equation by sine squared theta, you get this second equation. And when you divide the entire equation by cosine squared theta, you get this entire third equation. The quotient identities are how tangent can be expanded. So tangent of theta is equal to sine of theta over cosine of theta, and cotangent of theta is equal to cosine of theta over sine of theta, so it's just flipped. The reciprocal identities show the relationship between sine, cosine, tangent, and cosecant, secant, and cotangent. So sine of theta is equal to 1 over cosecant of theta, which means that cosecant of theta is equal to 1 over sine of theta. And this relationship is the same between cosine and secant and tangent and cotangent. So you can use those. So the first example is tangent of x multiplied by sine of x plus cosine of x is equal to secant of x. And the problem wants us to prove this to be true. So first we can look and see tangent. Tangent is also equal to sine of x over cosine of x. So we can substitute that in for tangent and so we can substitute that in and write out the rest of the problem as usual. So it's sine of x over cosine of x multiplied by sine of x plus cosine of x equals to secant of x. And we're only going to work with the left side of the equation because we want to prove that it equals to secant of x. So we multiply this fraction by sine of x, and we get sine squared x over cosine of x plus cosine of x equals to secant of x. Then we continue to solve, so we want to get cosine of x to have a common denominator with this fraction. So we do that by multiplying by cosine of x, and we would get sine squared x over cosine of x plus cosine squared x over cosine of x. So now they have a common denominator, and we can easily add them to get sine squared x plus cosine of squared x over cosine of x equals to secant of x. So this first top part it's part of the Pythagorean identities, and so we know that it equals to 1. So it's 1 over cosine of x equals to secant of x, and using the reciprocal identities, we know that 1 over cosine of x is secant of x. So secant of x is equal to secant of x. And that is done. The second example is tangent squared x over tangent squared x plus 1. So we look at this and we can see that we can expand tangent squared x using the quotient identities. So it'll look like that. Sine squared x over cosine squared x all over sine squared x over cosine squared x plus 1 is equal to sine squared x. And again, we're only working with the left side. So using this, we can look at this bottom equation and try and get them to have common denominators so we can simplify it, which would mean multiplying by cosine squared x. So now it's sine squared x over cosine squared x plus cosine squared x over cosine squared x on the denominator. This means that now that they have common denominators, we can add them to look like sine squared x plus cosine squared x over cosine squared x. So now this looks very familiar again. And sine squared x plus cosine squared x is equal to 1. So if we multiply the reciprocal of the denominator by the numerator, like this, we can get sine squared sine squared of x multiplied by cosine squared x is equal to sine squared x multiplied by cosine squared x over cosine squared x, because these multiply with each other and the bottom ones multiply with each other. Okay, so from this, we know we can cancel out this denominator and this numerator because they are the same, so they're equal to 1. So that leaves us with sine squared x equals to sine squared x. And the problem is done. Congratulations. I hope you enjoyed. I hope you could understand. And thank you. Have a good day.